Hi, how's it going? Thanks for tuning in to Match Data Pro. Today we are going to dive into our fuzzy matching module. The first thing we will need to do is import one or more data sources. It is important the order in which you import the data. I will explain why in a few moments. You can easily select all the imported data for matching or choose manually. We will import our master data first, and then we will import our prospect data after. Now that we have imported the data that we want to match, we need to define how we will match. This means we must define a relationship between the data sources. The way we can read this screen is to compare the column header to the row label. Each checkmark represents a match event between two data sources. The Within Matching option looks for similar records within each data source. In this example, we would search within the master data and within the prospect data. The Between Matching option will search for similar records between the master data and the prospect data. Of course, the All option will look for both matches within and between. This interface allows you to customize the relationships as well in order to meet your matching requirements. So this means that we have the option to match one-to-one, one-to-many, or many-to-many. For today's example, we will just do a between match, so we can find similar records between the master and prospect data. Next, we will map the data source columns together. By default, the tool maps similarly named headers. As I mentioned before, it is important to consider the order of which you import the data. The output data column headers will come from the data source that you imported first. However, you can see there are 3 columns in the prospect data that have not been mapped. This means that these 3 columns will be appended to the right of the master data columns with the prospect data column headers. In addition to mapping, we also have a merge column feature that will automatically place all of the columns from the prospect data to the right of the master data. If you choose this option, then you only need to map the common key or criteria that will allow you to merge these 2 data sources. However, for today's example, we will use the Suggest Mapping option so that we can map the columns together. You can also save your custom mapping efforts as a template and reuse the mapping on other data sources that contain the same column headers. Now we have come to my favorite part, match definitions and criteria. We will begin by adding a definition and then adding criteria. We can choose between exact matching and fuzzy matching. The fuzzy matching algorithm uses a proprietary mix of several string similarity algorithms in order to optimize performance without sacrificing accuracy. We simply do not miss matches. For this example, we will leave the match percentage at 90%, and I will add another criteria with exact matching for this definition. You can see that I am adding a second definition now. I will add the same fuzzy match criteria and a different exact match criteria to this definition. Now a question comes up. Why do I want multiple definitions? The answer is, match definitions are like OR statements. We can find matches on definition 1 or definition 2 independently. The criteria within match definitions are like an AND statement. All of the criteria in a match definition must match in order to be a match for that definition. This strategy allows us to define multiple ways to identify similar records, even when you might not have complete data for all records. For example, you may have some records that have a company name and an email address, but some may be missing the city name. And you may have other similar records that have the same company name and a city name but are missing an email address. By using MDP fuzzy matching, you will see all of these matches grouped together thanks to our multiple match definition logic. Next, let's take a look at scoring. First off, you must know that when we run a match, we first compare all records with each other and obtain one-to-one matches based on the definitions. These matches are called pairs. Once we finish finding all the pairs, we then group them into larger groups. With respect to scoring, we have 2 options. The first and default option is pair-based scoring. This will display the record's score in relation to the specific pair it was matched with. The second option is group-based scoring. This will display the scores for all records in the group in relation to the first record in the group. Pair scoring will generally be higher than group scoring, so you should analyze your use case to determine which option best suits your needs. Next, let's check out grouping options. We offer 3 strategies: partial, complete, and complete plus bridge. Partial match grouping will group records where every record matches at least one record in the group. This allows a kind of spider webbing effect and is useful when your objective is to capture every possible similar record. It is recommended to be conservative with your match criteria when using this option so that you minimize the possibility of finding false positives. The second option is complete match grouping. This option is the most conservative because it will only group records where every record in the group matches all of the other matches in the group. This is the best option when you cannot allow any false positives in your match groups. For example, this option is commonly used by government agencies. The third option, complete plus bridge, is a proprietary MDP grouping solution designed to address cases where complete match grouping is required, but a record can legitimately belong to multiple groups. With this method, a single record may appear in more than one group. When this occurs, we introduce a new column called the bridge column. This column assigns a bridge ID to records that appear in multiple groups, serving as a linking mechanism to maintain connections between them. We will now run the match and wait for the match event to complete. For any completed match, you can access a match info report that provides detailed insights into how the data was matched. This is especially useful when managing multiple match events, allowing you to easily reference the match configuration. Now let's take a look at the match results. In the first column, we can see the group ID. This will flag the matched records together. In the second column, we can see from which data source the record came. The third column shows the record ID. The fourth and fifth column show the paired record data source and ID. Each group has a master record. By default, it is the first record in the group. Definitions matched will show all of the definitions that were matched for the specific record. Next, we can see each criteria and its related score, and finally, the aggregate definition scoring. The criteria and definition scoring is displayed for each definition. In Group 2, we can see that the definitions matched shows 1 and 2. This means that these 2 records matched on both of the definitions that we created. The results are sorted by the best score by default. This means that the fuzziest records, closest to the fuzzy threshold, are at the end of the table. Here we can see in Group 88, the company name has a 90% similarity. If we visually inspect the 2 names, it appears that this would be a good match. Matching is case insensitive, so even though the city names have different casing, we consider them to be an exact match. Group 87 is very similar in that the name was a 92% fuzzy match, and the other criteria was an exact match as per the 2 definitions criteria. Thanks to the MDP fuzzy matching, we were able to capture match groups like 85 through 88. So, finally, we are happy with our results. And now we will want to prepare an export from the fuzzy matching module. We will start by creating a name for the fuzzy export. Next, we can leave the default to export all data sources, or we can select individual data sources that we want to export. After this, we will choose one of the 4 export options. First, we can export all data, which includes both matches and non-matches. This will include the group ID column, which will flag the matches together. Second, we can export matches only. In this option, we can also filter based on the score of 1 or more definitions. This is helpful if we want to separate our high confidence matches from our lower confidence matches, of which we may want to manually review. Third, we can export all non-matches or unique records. And fourth, we can export a deduplicated set, which means we will export all non-matching records plus 1 record per group, which will be the master record. We will discuss master records in a subsequent video for master record assignment, overriding, and enrichment. This export will be available as an input for other modules like profiling or cleansing, or we may go to the export module and prepare an export file for download. Thank you for watching this video. We look forward to seeing you again soon.